test is similar with the z-test. Same steps of hypothesis testing and same formula, but it has lower than 30 samples. To solve this, there is an additional things to do in step 3. Finding the critical z-value. Since it is less than 30 samples, we must get first the degrees of freedom, which is the sample size minus 1, then locate the z-value of its corresponding degrees of freedom and alpha value.
So in the problem, we are only given the mean, which is 70. So to find the other three values, such as the standard deviation, the sample size, and the sample mean, we need to refer from the data. So let's call the data given as X. We have 92, 62, 75, 68, 83, and 95. We should add them all together and we'll get 475 and divide it by the sample size, which is 6. So we will get the answer of 79.17. That will be our sample mean. So our mean will be 79.17 and the sample size is 6. To get the standard deviation, we have to use this formula of square root of quantity summation x minus the average x bar quantity squared over n minus 1. So we need to substitute these values. So square root of summation from 1 to 6, since we have 6 samples, and then we should substitute our x bar with the mean that we got, 79.17, and then n with 6, since we have 6 sample sizes. So we will get 13.17 if you input it in a calculator. So our standard deviation is 13.17. Now we have all the given data. We can proceed to the t-test hypothesis testing. So it's like in the z-test. So step 1, we need to identify our null and alternative hypothesis. So our alternative hypothesis, the claim, which is mean is greater than 70, and our null hypothesis is that mean is less than or greater or equal to 70. Then our step 2 is that there's no alpha value, but it put their 98% confidence level. So if we look in the t-table, we will get a value of 0.10 if it is a one-tailed test. Since ours is a one-tailed test, so our alpha value is 0.10. In step 3, we need to identify the critical z-values. So we have a sample size that is less than 30, which is 6. That is definitely less than 30. So we will use degrees of freedom. So degrees of freedom is equals to n minus 1, and substitute n for 6. 6 minus 1 will equal to 5. So in t-table, we will look at 0.10 alpha and at 5 degrees of freedom. And we will get the z-value of 1.476. So our step 4, we need to calculate for a t-value we are looking for. So 79.17 minus 70 over the standard deviation of 13.17 over the square root of 6, since that is our sample size, and it will equal to 1.71. So for step 5, we need to input the values in a normal distribution curve. So we need to locate the value that is our critical z-value, which is 1.476, and shade that region. This will be the rejection region, and the unshaded region will be our non-rejection region. Then we locate 1.71, our t-value from the formula, which is in the rejection rejection area. So we need to reject HO since it is not inside the non-rejection area. So we reject HO, which is mean is less than or equal to 70, and we should accept HA, which mean is greater than 70. So for our step 6, since that our HO, the null hypothesis, was rejected, therefore there is enough evidence to conclude that the class mean on the math test is above 70. So that is the answer for this problem.
In this problem, we have the given of mean, which is 5.7, sample mean, standard deviation, and sample size. Step 1. We will take the HO, M is equals to 5.7, and HA, M is not equal to 5.7. Step 2. We have the alpha value of 0.05. Step 3. We have the critical Z value. Since our sample size is less than 30, we need to use the degrees of freedom. 5 minus 1 is equals to 4. If we look into the t-table, we'll get the value of positive negative 2.776. Step 4. We need to compute. Sample mean 7.4 minus the mu of 7.5 over standard deviation of 2.88 over square root of 5, which is equals to 1.32. Next, we need to input it in the normal distribution curve. We need to plot the positive and negative 2.776. We need to shade both sides because it is a two-tailed test. We don't need to reject HO because we get the value of 1.32, which is in between the critical value, and it belongs to the non-rejection area. Last, step 6. For our conclusion, since we did not reject HO, we can conclude that it is like that his team's score should have come from the national distribution.
We have a given mean which is equals to 4.7. We have a given x which is equals to 5. Our standard deviation is equals to 0.452, and our n is equals to 22. Step 1. We need to find the probability of the sample mean that m is not equal to 4.7 and m is equals to 4.7. So for our step 2, we need to identify what kind of test we should do. Basically, looking at the step 1, it is equal and not equal, so we should run a two-tailed test with this problem. For our step 3, we need to solve the critical z value. Since our n is less than 30, we need to find the degrees of freedom, which is basically n minus 1. So we need to substitute n for 22 minus 1, which is 21. So our critical z value is positive and negative 2.080. For our step 4, we need to solve for the z. So the formula is indicated into the topic introduction earlier, and the answer in this problem is 3.11%. After computing for the z, we need to graph the 3.11% into the normal distribution curve. So we need to label it 0, 1, 2, 3, negative 1, negative 2, negative 3. The positive 2.080 is located here. And since it's a two-tailed test, we need to label the negative 2.80 also. So our 3.11% is located here, and 3.11% fall out in the rejection region. So we need to reject HO. So for our step 6, since HO was rejected, there is enough evidence that the GPA of the 22 pupils is different from the population of GPA. So basically, computing all the given resulted to the rejection of HO, and we need to accept HA that m is not equal to 4.7.
The test for one proportion is a hypothesis test. Hypothesis testing is testing whether an answer or a test is valid or is repeatable. For this test, or the z-test for proportion, we use the critical value approach. And to answer the question, here are as follows. For the first step, you determine your HO or HA, null hypothesis and alternative hypothesis. Second step, you determine your alpha values and what type of test, either one-tailed or two-tailed. For the third step, you determine your critical values, wherein it is possible you can reject your HO. For the fourth step, you use this formula. P hat is the sample proportion minus PO, the population proportion, over the square root of PO minus 1 minus PO over N. After you get the answer, you then draw the graph with the curve. And then you determine the critical values, and then you graph your answer. If your answer falls within the rejection region, or the critical values, you then reject HO. If it falls within the non-rejection region, or the unshaded part, you do not reject HO, and you don't reject HO. Afterwards, you write down your conclusion.
So, after analyzing again the problem, it would give us a p-hat of 13,173 over 25,468, or 0.5172. For our population, it would be 25,468, and for our P, it will be 0.5. For our step 1, we have to get the HO, our null hypothesis, and HA, our alternative hypothesis. So for our HO, P is less than or equal to 0.5, while for HA, P is greater than 0.5. For our step 2, we would need the alpha value, which would be 0.05, and this would be a one-tailed test. For our step 3, we would need the z-value, critical z-value, which would be 1.645. For our step 4, we would be solving the problem. 0.5172 minus 0.5 over the square root of, sorry for the error, that must be 0.5 multiplied by 1 minus 0.5 over 25,468, which would give us 5.49. For our step 5, we would be graphing the z-value. As you can see, I am now shading the part or the region of 1.645. And we would locate 5.49. Since 5.49 is located in the rejection area, we would reject HO and accept our HA. For our step 6, which is our conclusion, we can say that there is sufficient evidence to conclude that boys are more common than girls in the entire population.
So in the problem, we have our given of p hat, which is 82 over 100 samples, and then, or it is equal to 0.82 or 82%. Next, we have the sample size of 100 doctors, and then we have the proportion ratio of 9 over 10, or 0.9 or 90%. So we begin with step 1, which is to define the null and alternative hypothesis. So our null hypothesis will be that P is equals to 0.90. Then our alternative hypothesis is that P is not equal to 0.90. So next we will proceed to step 2, and it is about finding the alpha value and what type of test are we going to use. So in the given, it is given that 0.05 alpha we'll be using. And since we are dealing with equals and not equals, we are using a two-tailed test. Step 3, well, that should be 3, is that we need to find the critical z-values in the t-table. So we're looking in the t-table, we have 1.960, positive, negative 1.960. So next, we have step number 4, which is to compute for the z value. So 0.82 RP hat minus 0.9, the population proportion mean, over the square root of 0.9 multiplied to 1 minus 0.9 over the sample size of 100. It will give us a z value of negative 2.67. So our next step, which is to input it in a normal distribution curve, step 5. So there we go. We're going to draw a normal distribution curve. Then we need to input the critical z values of positive and negative 1.960. So there we go. So we put the values of positive by negative 1.960 and shade the region to remind that when the z value is in these regions, it will be, the HO will be rejected. So since our z value is negative 2.67, it means that our null hypothesis, which is P is equals to 0.90, is rejected since it belongs in the shaded region, which is the rejection region for the null hypothesis. And then we will accept our alternative hypothesis. So step 6 is that we conclude. So since that our null hypothesis is rejected, therefore the claim that 9 out of 10 doctors recommend aspirin for their patients is not accurate. So that concludes this problem.
Once again, to solve the problem, we first jot down the given. The population proportion, which is 80% or 0.8. The sample size, which is 100. The sample proportion, which is 73% or 0.73. And then we proceed to the first step. We write down the null hypothesis and alternative hypothesis. Null hypothesis being HO, which is P is greater than or equal to 0.8. In the alternative hypothesis HA, P is less than 0.80. Then we proceed to the second step, wherein the alpha value is set at 0.05 level of significance. This test is one-tailed test because it uses greater than or less than. Third step, we determine the critical values. Critical value is at negative 1.645. Fourth step, plug in the data into the formula. 0.73 minus 0.8 all over the square root of 0.8 times 0.2 over 100. The fifth step, we then draw the graph with the normal curve and determine the critical values. As you can see, the critical value is set at negative 1.645, which is right there. And our answer at negative 1.75 is within the rejection area, thus we have to reject HO. So we reject the HO and then accept HA. For the sixth step, we then make our conclusion. Since we reject HO, there is not enough evidence to support the claim of the CAO that at least 80% of his customers are satisfied.
A two-proportion z-test is used to test the difference between two population proportions, P1 and P2, when a sample is randomly selected from each population. This is basically the same as z-test for one proportion, same steps for the testing, except it uses two proportions and uses a different formula. We will use this formula to compute for the z-score, wherein P1 is the population number 1, P2 is the population number 2, N1 is the sample size of P1, and N2 is the sample size of P2. So in the problem, we have given the two proportions that we need to compare. So you have our P1 and P2, so our proportion 1 is that 68 out of 165 children who took a placebo got ear infections. And then our second proportion is that 46 out of 159 children who took EXO got ear infections. So our first sample from the first proportion is 165, and our n sub 2, which is the second proportion, the sample size of the second proportion is 159. So let's proceed to step 1. So step 1 is to determine the hypothesis. So since that we are finding that XO prevents ear infections, or we are finding that if the placebo group has higher infections than the EXO group. So our alternative hypothesis is that P1, the placebo group, has higher ear infections than EXO group, which is P2, and our null hypothesis is P1 is less than or equal to P2. So let's proceed to step 2. So for our step 2, we need to determine what type of test and the alpha value. So our alpha value will be 0.025, and since we are dealing with greater than and less than, we are going to have a one-tailed test. Let's proceed to step 3, which is to identify the critical z values. Like in the other problems, this finding a critical z value can be found in the t-table with correspondence to what alpha are we going to use. So our critical z value will be 1.960. So then, for our step 4 is to compute for the z-score. So we input our P1, so 68 over 165, minus our P2, 46 over 159, all over square root of so since it's very long, we could substitute 68 out of 165 P1 and 46 out of 159 P2. So I have P1 quantity 1 minus P1 quantity over the sample size, the first sample size 165, and then we will add it with P2 quantity 1 minus P2 quantity is close over 159 on the second sample size. So after we input that in the calculator, we will be able to get the answer of 2.34. So let's proceed to step 5, which is to input the values in the standard distribution curve, just like the other tests that we have done, the other problems that we have done. So there we go. We need to locate our critical z values, that is 1.960. There we go. There we go, 1.960. We will shade this region so that we will be reminded that if the z-score exceeds this, it will be rejected. And since our z-score is 2.24 and exceeds 1.960, we will reject HO. Since it's 2.34, it's farther than 1.960. For our step 6, Since we reject HO, our null hypothesis, there is significant evidence to support the claim that XO helps prevent ear infections of the children.
In this problem, we have the given P1 is equals to 15% and P2 is equals to 21%. Sample size 1 is equals to 200 mothers. Sample size 2 is equals to 200 general practitioners. For the step 1, we'll take the HO. P1 is equals to P2 and HA is equals to P1 is not equal to P2. Step 2. We have the alpha value of 0.01 and it is a two-tailed test. Step 3. We have the critical Z value. If we look in the table, we'll find Z equals positive negative 2.576. Step 4. We need to compute. Z is equals to 0.15 minus 0.21 over square root of 0.15 times 1 minus 0.15 over 200 plus 0.21 times 1 minus 0.21 over 200, and it is equals to negative 1.57. Step 5. We need to input it in a normal distribution curve. Since it is two-tailed, we need to plot positive negative 2.7576 and shade it. Negative 1.57 is part of the non-rejection area, so we will not reject HO. Step 6. For the conclusion, since we failed to reject HO, there is not enough evidence to conclude that there is significant difference between the two proportions.
In this problem, we have a given of total numbers of girls and boys. For the girls, we have a given of 53 and 81. So we need to add it, so we will get a total number for girls which is 134. For the boys, we have a given of 18 plus 43, so it is equals to 61. For our P1, we will have 53 over 134. For our P2, we will have 18 over 61. our N1 is equals to 134 and our N2 is equals to 61. So for our step 1, we need to know what is our claim. Our HO is P1 is equals to P2. And basically, our HA is P1 is not equal to P2. So looking at this step 1, we will know what kind of test we should run. So we will proceed to step 2. We have an alpha that is equivalent to 0.05, and we will indicate here what kind of test we should run. Observing step 1, we will use a two-tailed test. Step 3, we need to solve for the critical z value. Looking at the table, using alpha 0.05, we will get a positive negative 1.960. So we will proceed to step 4. Using the formula indicated into the topic introduction, we will solve for z. So we will use 53 over 134 minus 18 over 61 over square root of 53 over 134 times minus 53 over 134 over 134 plus 18 over 61 times 1 minus 18 over 61 over 61. So, using this formula, we will get a final answer of 1.39. For the step 5, we need to graph our 1.39. So we will draw a normal curve distribution and label it. So our positive 1.960 is located here, and our negative 1.960 is located here. We will show where is 1.39 located. So we will not reject age O. For our step 6, we need to conclude. So we need to conclude that since our HO was not rejected, because our 1.39 fall out on the non-rejection region, there is not enough evidence that a gender difference exists for our perfectionism.
And that's all for this video.
Hit like, subscribe,
And ring the bell to get notified. Thanks for watching. See you in our next video.